In this video, we're going to cover working with the WAGO Perspecto CP TV panels and configuring a CANopen network. With these panels, you have CANopen Master functionality. It has two options with regards to the CANopen ports, a D-sub connection or an RJ45 connection. Along with the panels, we're going to be interfacing the WAGO 750 series IP20 CANopen coupler and the WAGO 767 Speedway IP67 CANopen coupler. I'm going to show you the connectivity, which is all from WAGO, the cabling, the actual field bus connections, and of course how to write the code and set up the Perspecto CP TV panel as a master device for CANopen. Now you can see the WAGO Perspecto CP TV panel running the actual executable code on here. We have our WAGO IP20 node, where you can see we have dip switches on the front and the CANopen connectivity here. We also have, with the dip switches, we use these for the baud rate and node ID itself. And of course we have full setup and configuration documentation on these. Just wanted to point that out on here, how easy that is to just basically set up the baud rate and node ID. We also have on this side the Speedway product, our IP67 CANopen coupler with built-in digital inputs, and then a digital output card as well that we'll be toggling the outputs on. And then of course in here we have some dip switches for configuration of the device as well. So just wanted to show you here live the actual system that we're going to be working with, and then now we're going to get into configuring the devices and writing the actual code. Okay, I just wanted to point out quickly the ports on the back that we're going to be utilizing for this exercise. Again, mainly the CANopen ports. You can see this is the CAN0 port, and this one is called the CAN1 port. You can either use the D-sub connections or an Ethernet connection, where you could just plug in an RJ45 connection into the panel and then take your standard maybe connectivity to your couplers, whatever that may. In this case, like the with WAGO series, we use the MCS connectivity. So either one of those, again, can be utilized for CANopen. We have our Ethernet port, of course, as previously discussed in other videos, for, in this case we're going to be using it primarily as just a programming port for the code assist system to the CPTVs. And we have a couple other serial ports over here, 232, 485, some of our configurable power, USB, and so forth. We'll discuss some of these more in detail in other links or other videos when we talk about backups, restores, and things of that nature, and data logging. But in this time, again, our primary focus is going to be on the CANopen ports. This is also a CANopen connector from WAGO with a terminating resistor built right into it. You can see the on-off here. So again, just the different things that you can utilize with this system as far as the different various ports. But again, we're going to look primarily at the CANopen, how to set that up. Basically, from the standpoint of the hardware side, it's just a matter of plugging in the cable in this case, and then we'll talk about setup from the panel itself and within Code Assist. Okay, we're going to use the serial D-sub connector on the back of the panel, which is the CAN1 port. But I just wanted to show you, if you're going to use the RJ45 connectivity, there is one place you may want to go with regards to setup of that port. You can go into the WAGO Control Center, open that up. There's various things we've covered in here before with regards to setting up the IP address of the device, backup, restore, FTP ports, and so forth. But again, focusing on CAN here, we're just going to go to this Advanced tab, and you can see here the CAN0 bus termination. Again, if you're using the RJ45 connectivity, you want to have this enabled for your CANopen communications. So again, just wanted to briefly just show you that real quick before we move on to writing some code and loading it on the device. Okay, so now we're ready to start with Code Assist to program the CPTV. And what we're going to do first here is just get started by clicking on a new project, and then we're just going to select the appropriate controller. In this case, again, we're discussing the Perspecto CP TVs, and you can see here we have the 762-3104, the 10.4 inch. We have our visualizations in here. So we can have our web visualizations and other things that we can enable on the device. We'll do some other things later on with regards to network functionality and things of that nature, sharing network variables. But again, our focus here is on CANopen. We will create a visualization, so we want to make sure we have that enabled on the device. We are going to create a program in structured text. So we'll just do this to start or create our main POU. And what I'm going to do first, of course, before I go into any of this, is set up the CANopen configuration, the CANopen Master. So I'm going to go to my Resources tab now, and go to PLC Configuration. You can see here for the controller, I'm going to right-click on PLC Configuration, append sub-element, and insert a CAN Master. Now, this would be the CAN Master port, the CAN 0 port. If I wanted to use that, come in here and set up and do some things in here, I could do that. In this case, as I mentioned, we're going to be actually using the D sub port, so we'd actually insert a second master in here, and now this is the CANopen port that we're going to actually utilize. We can just ignore this one. We don't have to use it in any way, shape, or form unless we choose to. So in here we have our CAN parameters, and what we can do from here is just set the device up with regards to how we want to configure the device, what's the node ID and so forth. In this case, we can just set this to 1 if we want. You want to have the automatic startup and support DSP 301 version 4 and so forth in here. This is to help us use the configuration files for CANopen from WAGO within Codesys. So here the baud rate is 125K, as I previously mentioned. That's what we're going to utilize here. So basically for this point, it's really all we have to do. Once we've set this up, I'm going to right-key click on the CAN Master, and then I'm going to insert the devices we're going to communicate with. As I mentioned, it's a 750-337. We'll insert one of those, as well as the 767-1501 for the Speedway system, so IP20 and IP67. Alright, so from here we can select the actual coupler that we're going to work with. Come into our CAN parameters, set this, in this case it is 2, but we can set the node ID to 2 here. You have things like node guarding that you can utilize for monitoring your communications between the devices and things like that, whether it drops out with the master or not. You can set this to 5002 here, and then of course we can also come in here and configure the device itself, what's attached to the device as far as the coupler and the I/O itself. In this case we just have one module. We have the 1506, so I'm going to add that to the node and the configuration, and you can see here you have your output and input bytes. Okay, so we're just going to put in here our variable names, if you will, just pointing to the entire byte of information, and we'll just okay. So now we can actually point the data that we're going to create right into the entire byte, or of course we could always go down to the bit level as well, and you can see the addressing on here with regards to that, assigning variable names or pointing variables to these addresses as well. But just to simplify things, we're just going to point it to the entire byte. And then on the 767-1501, We're going to go to our CAN parameters again. Again, we can set this to 5 seconds, 2 here, and then we can also come in and configure the node. Now in this case, you always want to build from right to left. It's a little different than when you're building an actual node, so it drops it into the right location. So in here I have a 7674801, which is our output module here. I'm going to add that first, and then I'm going to come back to the 1501 and drop in the 8 digital inputs that are already built into the coupler itself. So this is finished here. And like I said, there's other things you can utilize, other things you can do as far as emergency telegrams, heartbeat settings, and things of that nature. Again, just going to go through the basic startup of a CANopen system. So now we're just going to move on to the second node and put in, again, variable names in here. And so forth. So again, now we've configured the node, we've assigned a few variable names to the actual configuration of the nodes, and now I just want to come in and just create, like I said, just a few lines of code in here. So we'll just come in here. So getting started here with the code. Couple ways, of course, we can do this. We can just start writing our code, declare as we go, and that's what I'll do the first line here, just a little timer pulse, and then I'm just going to, like I said, create this. So I'll explain this in just a moment. Like I said, just putting in a few lines here. And again, in this case, I'm going to create this and then just declare this timer pulse as a function block in just a moment. And also, of course, like I said, you could have declared this up here in the editor declaration field, and then of course just put the structure in, which is what I'll do with the next one, just so you can see how that's done as well. But so basically here I have timer pulse, I have input, an output here, and a preset time for when it's going to cycle as far as a function block. Now in this case, what I want this timer pulse to be is, I'm going to look this up just so you can see it. Standard function blocks, and you can see here this blink function block here. Also, I have some others for timers and things like that, signal generators, timer on delays, and all that. And this is just going to be a timer pulse here. And okay, and now you can see it's declared up here. Now this timer pulse out, this is going to be a Boolean. You can see it's just a Boolean output here. And that's it for that line. And now I can come in and actually, I'm going to declare it first up here. And we're going to declare C1 as a counter up. And then when I come down here, use F2 in the actual editor, and I can look for local variables. I'll find my C1, and now you can see the actual structure of the function block. So with this one, it's going to toggle, and again I could just use my F2 again, look for that TP out, and then we'll have a count reset as a Boolean as well. Preset value, if you're worried about that, I can just put a value in there. I don't need anything on the output. And then we can just have here
our count. Let's call it C1 count. Okay. And our C1 count is going to be a word value. We just type that in. And then down here, I'm just going to put in this count reset. And when the C1 count is, we'll say, greater than 254 in this case. We're just dealing with a byte of information. So basically we have a timer pulse up top here, and we're just generating this pulse on and off. This is going to increment the counter. I'm setting my reset here when the count gets greater than 254. Again, we're just going to use this count value to push information into one of those bytes of information on the output side. So now we want to, or we have to convert the data because it's unsigned integer value. We have a word output. We need to convert from one data type to another. So here we'll just put in a new variable, and I can use again F2, look for my conversion operators, and as I said, we're looking for a word unsigned. There we go. And then we just need to put in our value here from that word value. All right. And pulses, of course, is going to be a unsigned integer. Okay. And we could, for example, just to view the data, we could put in our information with regards to the input that we're going to view on the CAN by in. And then what we do from here is take that pulses information and of course put it into that CAN out. So here we can go CAN out 1 here, and then just again make that equal to this pulses in here. All right. So this information, of course, we can look at the inputs. I have a few of the outputs wired back to the inputs. We can see the values in here. We can also see this information being pushed into that output byte, and we'll create a visualization pointing to that as well. Now I'm just going to put some information in kind of just a different way into the Speedway product, which was our CAN in byte 2 and CAN in out byte 2. So if we wanted to look at the information just for the CAN inputs, we could do that. Nothing's really going to be there because it's not wired in. But what we could do is just come up here. I'm just going to create another variable real quick. And this will just be, okay, and again, this is just a function block within the libraries of Codesys. So now I can just come in here, find my blink function block. Again, you can see now the structure here is just go right into it. I'm just going to set this to true, and we'll just do a slightly different time interval here for the on-off state, and then we'll just have our output. All right. So this is going to again cause our pulsing action just at a different rate. So you can do it this way with a one shot, look back on itself, or this way with this little signal generator blinking on and off. Again, just trying to show you different ways within Codesys, the different libraries and everything. Here's our blink out. We need to declare that, of course. Okay, next, I just want to put in another counter. So I'm just going to declare a new counter up, and then I can come down here, F2 again, and find my counter, drop it in here. Again, you can see everything's laid out for me. And now I can just put in my information as far as what I want to increment the counter. For example, is going to be this blank out. We can set this reset to when the count is completed. So what I'm going to do is just call this count done. Okay. And then our preset value here, go to 5. And then our output would be, of course, I'm done here. And then our C value here would be our C2 count. And this, of course, is a word. All right. So now I have another count value for my data that I want to push into the Speedway product. Again, just a byte of information. So now I can come in here and select from my list of global variables our byte 2. And just have this using the, again, conversion operator for word unsigned integer, and then we're going to take that C2 count. Oops. Again, it's not case sensitive, so it doesn't really matter, but just make it clean here. Alright, so we have now this signal generator function block here, this blinking function block with a counter. We're going to generate this data in here, and then we're going to push that information to the output byte on the Speedway product. It's the output card on there. I'm not going to worry about looking at CANin byte 2 on this one because, again, we don't have anything connected to that part of the I/O. Alright, so now we just want to rebuild the project, make sure everything is correct and there's no errors here. So we're ready to proceed forward. And the next thing we want to do is create a visualization so that we can display this information on the actual CPTV panel. So I'm going to come into the Visualizations tab here, Visualizations, Add Object. I'll call it PLC_Visu. If you've seen in the other previous ones, you know that's what we have to call the main screen or page, if you will, for the visualizations. So in here, there's a lot of different things I can do. I can display the entire byte of information, bits and pieces of the information, whatever, but I just wanted to put in a few indicators in here just to show the on-off state of a few of these signals. So now we can just find which byte we want to write to. Again, in here we're looking at specific bits within the byte. So this is one way you can do it. You can also just copy, paste, and change this. You can also use direct addressing. So, you know, depending upon the byte and the specific address, you can use QX, QW, QB, and stuff like that in here as well. Just have another color in here. Change the state. Okay, and I'll just put one more in. and just some discretes going on off. And then just the next thing I want to display is just the entire byte of information. And now what I can do is just build this meter here to point to the actual variable. So, all right, so we're going to set our start and our end scale. Okay, our main scale in this case 40, subscale 20, and then of course what information we want to look at here on this meter. We could just leave it like it is. We could also set something like color areas in here. So you could do, for example, from 0 to 40, that's red, and then 40 to, say, 60 as yellow, and then 60 to 60 as green. Okay, so we can see here, sweeping meter, and then just drop that in. So now we have this scaled to our input, our data as far as the byte of information we're going to look at. And again, just something real quick just to show you how to create a few visualizations. We'll go into more detail about other visualizations, that you can create. You can see up here different things, bar graphs, histogram, and alarm tables, trending, and so forth up here that you can add as well. All right, so now our visualization should be complete. 0 errors still, good on that. And now what we want to do that's a little bit different than what you've seen with some of our controllers is we need to create a task where we actually call the PLC_PRG. So in here, I'm just going to add a new task, make this freewheeling, and then in here, I'm going to append that, and then we'll just call our PLC_PRG. And you have to do that with the Perspecto panels. Again, if you're used to our controllers, just by default, your PLC_PRG is your main routine that's called and executed and so forth. In this case, you do actually have to configure this under your task configurator. All right, so we have everything finished here. Web visualization, everything's on and good to go. And now I just want to make sure that I log into the appropriate device. It's already been set up here. 105055 is the controller, port settings, and so forth. Okay, and then I want to go online and log in. Tell me there's no program on the controller. Yes. And now that it's online and loaded, use F5 to execute or start the program. Okay, so now I can just check the visualization, make sure everything's running, incrementing, working here within the actual code itself. I can look at the PLC config, for example, and expand this and see that the information is being written into those bytes. And you can see the input where I've just kind of wired some inputs back on the outputs and so forth. Okay, so this is looking at it from the codesys perspective. Now let's go and look at the actual equipment running, and we can see the visualizations and so forth.
Okay, so now you can see the project we just created with codesys running on the Perspecto CP TV panel. Again, all the executable code is running on this device. This is also the CANopen Master as well. You can see our CAN output byte 1 here running to the IP20 system and toggling the outputs on and off. Again, just looping back the inputs just to show you the actual outputs toggling on and off, feeding back to the IP20 system, and then the output byte 2 here you can see on the actual coupler for the 767 Speedway product, which is an IP67 CANopen system. So the entire system, again, that we're looking at here, whether it's the IP20 products, IP67, the CPTV panel, the cabling, the connectivity, all of that provided by WAGO. I hope you found this video informative, and thank you for your time.